Now let me write the procedure for inserting in a heap. That is the procedure for rearranging the elements. I will write on the procedure here. So insert function I have written. Insert function is taking a parameter, that is array, where heap is stored. So example, this array, I have changed the name A. So like A is an array, this array. Then n is the index of recently stored element. So how we call that insert is, first of all, I will store the value here, for example 50, then I will call that insert function. So what is n? N is this one, index 10, where the newly inserted value is there. Okay, then what I have to do, I have to take an integer pointer I here so that it can go on checking the elements, and also I should take this in a temporary variable. So I need some variable temp and also I is initialized to 0. I should take this element in a variable temp 50. So 50 is gone, sorry, 50 is copied here and I is pointing here. So I should point on n. Then this temp I should copy here, temp assign A of n, that is the last index. Now what I have to do, compare the temp element with the parent of this index I. If a temp is greater, copy that element at A of I. Go on doing that same thing. How long? Until you get some element that is greater than temp, stop, or else you have reached 1. So as long as I is greater than 1, I should continue. So this copying can be done using loop, that is while loop. So I will write on the loop. So while I is greater than 1 and temp value, the value that we have inserted, is greater than its parent. So parent means I by 2. Integer division, it will take floor value. So A of I by 2, parent's value. If so, if its parent value is smaller, then we copy that element here. So from A of I by 2, we will copy it in A of I. Copy the element from A of I by 2 to I. Then bring I here at this place. So I assign I by 2, I assign I by 2, will bring it here. That same procedure is repeated. When the loop, while loop stops, when it stops, either you have any value that is greater than temp or I has reached 1. Then copy this temp wherever I is pointing. Temporary value, the value in a temporary variable, that is the new element that we are inserting, is copied at A of I. That's all. This is the procedure. So how to call this one? First of all, you write down the value in an array, that is in a heap array, and then call this insert function by passing this index. It will rearrange. Actually, it is rearranging the values. So this is the insert function. Now analysis. How much time it is taking for inserting one element in a heap? We always insert a new element at the leaf, as a leaf, last level, right? Then we will try to arrange the elements. So for the arrangement, the element will move up. At most, it may reach root. So it is moving up level by level. So total, how much time it is taking? How much work we are doing? So it is taking log n time. So it is taking time depending on the height of a tree. So what is the height of a complete binary tree? Always log n. Yes. So insertion time is always log n. So for inserting one element, it takes log n time. See, I have explained you this with respect to working what we have done diagrammatically or graphically. But if you want to know what is the time taken from the code, if you want to read, say this while loop is starting from n, and every time that value of I is divided and divided by 2 every time, again and again. So what will be the time? So how many times it get divided by 2? Log n base 2 times, log n base 2 times. So from the loop also, from the code also, program code also, we can understand that it is taking log n base 2 time. So next we have to learn how to create a heap, that we will look at in the next video.